So what is the basic code calculation theory and assumptions? There's quite a few of them. Pressure part calculation should be undertaken by qualified, experienced personnel only. So that will probably be your engineer. Simple equations to calculate minimum wall thickness of shells, header pipes, and tubes. So this is a few formulas. And guys, every time I just need to quickly select a pen. Every time that I basically mark a slide, please mark it accordingly, because that means it's an important slide for your assignment. Okay, so if I mark it like this, right up in that corner there, all right, you need to mark that slide as well. Okay, so in this case, mark it. T will be your thickness, all right, P pressure. This one here will be the ASME code, all right, and this one is the BS code. Or basically, you can use this one as well. That's the formulas for thickness, basically for shells, header pipes, and tubes. Basis for establishing allowable stress is outlined in ASME section 2 and also applicable BS codes. So both ASME and the BS base the allowable stress on either of the following: the minimum tensile stress, which is RM at room temperature, added the minimum yield strength, RE, T at design temperature basically, and the mean creep rupture, all right, SR, and this is also at design temperature. So that T there is basically for design temperature, all right, and that M there is basically for room temperature. Also, a design factor or factor of safety is applied to each of the above values. Okay, so always take into account that you need to allow for a factor of safety. Continuing the code calculations, BS codes allowable stress F equals the lower of any of the following, all right, the RM, remember what we said, that's room temperature, 2.7 or RET, 1.5 or SRT 1.3. Okay, so for openings built in a definitive pattern in a drum, the header or shell ligament efficiency method is applied, and we'll take a closer look at that as well. And for branches or isolated openings, thickening or reinforcement is determined using tabulated parameters or area displacement method. So there's two methods there. The one is tables, and the other one is basically the area displacement method. And again, we'll take a look at that at a later stage as well. There are a few considerations that you need to take into account for the code calculation theory and assumptions. Firstly, is calculations must take into account manufacturer's tolerances. Corrosion allowances must be added to all calculated minimum thicknesses. And design temperature is governed by margins above normal operating temperature for components. Okay, and these is exposed to products of combustion and also experience steam flow upset. So you need to take the pressure definitely into account. Certain dimensional relationship and limitations must be completed before the code calculation is deemed applicable. Also, equivalent materials are permitted in most cases, but requires approval by AIA and also the purchaser. All codes have definitive scopes of application, for instance, boiler code versus the piping code, all right? And then there's also the branch attachments. Things like acceptable forms and types of reinforcement vary with different design codes as well. So the important parameters are related to main pressure parts of a shell boiler. And we're going to take a look at the shell and also the furnace. In case of the shell, full penetration longitudinal and circumferential seam welds is needed. Longitudinal weld on two straights should be offset. All right, so you need to look at that. And also non-pressure part attachments and nozzles welds should not be located on or within a 40 millimeter of the edge of the seam welds or 2T. All right, twice the thickness basically. Okay, so what that basically means, if there's any part of attachment, if you have a vessel, all right, and you have your weld is running like that, Okay, that means 40 millimeters, all right, or 2 times the thickness, okay, from any of those welds. You're not allowed to put any attachments or nozzles or anything like that. Furnace, the maximum diameter is 1800 millimeters, and the maximum shell thickness is 22 millimeters. The end plates must be stayed. The plate thickness based on unstayed area and form of attachment. Tubes, the minimum thickness specified for straights and bends. And remember, we are looking at the code calculation theory. Branches, material allowable stress is 2/3 of the shell value. And allowance required for external pipe loadings as well needs to be catered for. So, welds and welded joints. Carbon content of alloy and carbon steel, it's larger than 0.35% for welding. Criteria governing a welded joint that must conform to the requirements of the applicable boiler design codes, depending on also country requirements and client requirements. Again, most countries' boiler codes are basically based on the American standard. So welding process, filament metal, welding procedures, the weld preparation profiles, all the reinforcement, weld defects, finished weld surface and profile, the heat treatments, extent of the non-destructive testing, all of these things needs to be taken into account with regards to your welds and welded joints. Overview of the design parameters. Boiler codes play an important part in determining safety requirements and design and constructional features. The most widely used is the ASME boiler and pressure vessel codes, and that's the American standard. This gives excellent guidance and basic design requirements, as I just mentioned previously. Sets safety rules for design, the fabrication, and also the inspection of boilers. Also, objective is to ensure safety and protection to life, equipment, and also property under normal and abnormal service conditions. So it requires a safety margin for normal service conditions, as well as the expected deterioration over the plant life or over the design life of the vessel. Boiler drum design. We're going to not take an in-depth look at this stage, but it will follow. Important considerations for the drum design. Tensile strength of steel used in the construction, the plate thickness, the drum dimensions, the efficiency of the longitudinal joints, the welds, and also the permissible safety factor. So you need to take all these considerations into account when you do the drum design. Importance of the stress in the design. Internal resistance offered by material against deformation by the external forces. And that's external forces on the material. Given by internal forces divided by area over which it is applied. And also the magnitude is important along with nature of the load and the resulting stress distribution. Drum design continuing. Design must consider whether loading is mechanical or thermal, steady or transient, where the stress pattern is uniform. When a material is loaded, it deforms or changes shape. Load need to cause permanent deformation is elastic limit, and load required to cause complete failure is ultimate strength. Okay, so please mark this as well, because you will come back to this. And these are important considerations in the design. So mark all these design ones. Okay, somebody's marking it on my slide. I'm not sure who, but guys, please mark it on your own slides or on your notes. Okay, boiler drum design. A comparison of tensile strength to actual working stress is called the factor of safety, and we mentioned that before. So in case of boilers, you may use a minimum, remember, a minimum factor of safety of 4. You can use higher, 6 if you prefer, which is a lot better. The minimum wall thickness as per ASME code is given by T equals P divided, or times R divided by SE minus 0.6 P. Okay, so in this case, P is the internal design pressure, and it is used in PSI, pressure per square inch. Okay, so if you in your calculation you are working with kilopascals, you need to convert that to PSIs, and then only then can you use this formula. Please remember that. S is the allowable material stress and design temperature. R is the inside drum radius in inches. So again, if I've given it to you in 0.5 of a meter, you need to transfer that to inches, and only then again can you use this formula. E is the efficiency of the weld joints or ligaments between openings. Say for instance, it equals 1 times for fully X rate with manual penetration. Okay, so that's the value of E. Internal design pressure, if unknown, can be determined from this equation below, basically this one. In this case, where TS is the ultimate plate strength, again in PSI. Obviously, T is your plate thickness. E, we looked at it in the previous slide, it's the efficiency of tube ligaments or joints, all right? R is the drum inside radius again, and Fs is the safety factor. That can either be given to you, or you need to make an assumption that you've used a safety factor or factor of safety of 4 or 5 or 6 or whatever the case, but in your calculations, please make a note of that. Furnace design considerations. Guidelines for furnace design. High, narrow boilers are generally less expensive than low, wide ones. Few large burners are less expensive as compared with more smaller burners. Burners must be located far enough from walls and the floor. This prevents carbon buildup and flame impingement and allows enough distance for flame to travel. Design must incorporate largest practical burner size and also adequate width and depth to ensure proper clearances. So, the number of burners must take into account the planned operation to meet various load requirements. It's also referred to as a turn-down ratio. So, if planned operation is for 20% of full load, the ratio is basically 5 to 1. Okay, 20% of 100%, so it's basically 5 to 1. Proper burner sizes is critical for proper and efficient functioning at lower loads. Plates and tubing. Plate design and thickness is a determining factor in the internal design pressure of the boiler drum, so the wall thickness. Maximum stress to which a boiler plate may be subject varies between 1/4 to 1/7 of the material tensile strength. Now, usually the material tensile strength will be given to you, so then you know the maximum stress to which a boiler plate may be subjected is 1/4 or 1/7 of the material strength. Generally, drums with thickness of 4 inches or more use SA299 steel plates, and their unit strength is about 75,000 PSI. SA516 steel plates have a 70,000 PSI, is used for drum thickness of less than 4 inches. Okay, 4 inches, that's quite thick, guys. Tube serves heat absorbing surface and provides flow circuits. They may be plain or fitted with extended surfaces in the form of fins or studs, may be straight or bent, and we'll take a look at a picture of a vessel as well, measured by the outside diameter, all right, may range from 1 to 6 inches in diameter, with a wall thickness between 1/16 and 3/4 of an inch. So the types of boiler inspections, external or operating inspections, they basically involve inspection of external boiler fittings such as the supports, also the external piping, plate and tube surfaces exposed to combustion gases and high temperatures, also inspections of the safety valves, the water column and the gauges, and also pressure gauges and blowdown valves. External operating inspections, it basically involves the checking for signs of expansion strains, rust, scale, debris, and other deposits. cracking, erosion and leakage, abnormality in safety valve pressure and blowdown gauge operation, bulging, blistering and sag, and also heat localization. So you can pick up on, say for instance, the paint, where the paint started swelling. You can pick up, for instance, heat localization there. Alright. There's a few ways of checking, and we'll get to those test methods as well. So the types of boiler inspections: internal inspection. What's the purpose? It is basically to check on the structural soundness of pressure containing components, and also to note any conditions that can affect its strength to confine the pressure. If you cannot confine the pressure, you're sitting with a problem and a risk. Trouble spots may vary depending on the boiler design, also the operation and the maintenance procedures involved for each boiler. So the internal inspection areas required internal inspection: all exposed internal metal surfaces for water treatment effectiveness and scale, and also for oil and other substances entering along with feed water. Oil and scale on heating surfaces lead to a weakening of the metal, causing a rupture. Corrosion areas next to a seam, okay, so you need to take a closer look to that as well. Always longitudinal seams of shells and drums for signs of grooving and cracks, and also fillets of unstayed heads for internal grooving. Stays and stay bolts are inspected for even tension and fastened ends for cracks. Manholes and other openings for corrosion, thinning and cracks. Opening to water column connections and dry pipes, which must be free of obstructions such as mud and scale. So you need to clean it as well, if you find any of those. Welded nozzles for weld washout, cracks and evidence of joint deterioration. Ligaments between tube holes in heads. Beading and flaring on tube ends for erosion, corrosion. Also cracks and thinning as well. The types of boiler inspections: stationary or jurisdictional inspections, basically form part of a state or country laws designed to provide protection against destruction to life and property. As I mentioned, most countries' vessel design are basically based on the American standard, that including Australia, but there are differences with regards to standards and procedures that differ from country to country. Mandatory periodic inspections are often carried out by AIA or qualified inspectors. Owners is required to arrange for these inspections at stipulated time intervals. So there will be a shutdown period where you need to prepare this vessel for inspection by the authorities. In the case of power boilers, this is usually consistent of a yearly internal inspection and an external inspection 6 months later. So you'll get a chance to inspect it. If you find any defects, fix it, and then 6 months later you will have a authority inspection. For low pressure heating boilers, inspections may be on a yearly or biannual basis, depending obviously on the jurisdiction. Types of boiler inspections: NDT or non-destructive testing, you all know that. And this is some of the testing methods I just mentioned earlier. Ultrasonics, basically portable equipment, extensively used for checking plate and tube thickness, useful in determining the causes of failure or repetitive nature, such as tube failure and water walls. After one tube has failed, the adjacent tubes can be checked ultrasonically and tubes that have thinned replaced before any failure. Similar tests are performed on tubes subject to fly ash erosion as well in power stations. Plate thickness around manholes, water legs, shelves and heads are ultrasonically checked for thickness for determining allowable pressure. Magnetic particle inspection, primarily used to detect the surface cracks, especially bends, chiefly used on piping and boiler joints. Radiography, extensively employed in field testing, excludes the likes of X-rays that are used to test welded repairs in boilers. Okay, and usually with a boiler, you will have a 100% inspection. Okay, so that means everything gets tested. Dye penetrating testing, used to detect surface cracks on piping and other welded joints, and also eddy current testing. Basically, a chief use is in looking for defects in non-magnetic tubes connected to a boiler such as a heat exchanger and condensers. So the eddy current basically works on a signature where they will have anything different from the signature will be questioned. Selecting the right boiler. No piece of equipment can be more important to a facility than a boiler. Proper boiler selection is quite essential in order to meet the needs of a particular application. Boiler selection is a critical factor in the design of any steam or hot water system. Important criteria for boiler selection. Firstly, is it steam or hot water? The codes and standard requirements, and depending on where you are and what country. Boiler load characteristics, and also the number of boilers. Important criteria for boiler selection continuing. Location and purpose of the installation, you need to take that into account. Performance considerations from the client side. Special considerations, and also the anticipation of future needs.